உள்ள வந்துட்டேன். சிவப்பிரியானா? Bebekse. Hadi.
Hello? Hello?
Yes, ma'am. Good afternoon, ma'am.
Good afternoon.
Uh,
Sorry for the delay.
no problem, ma'am. Good afternoon, participants. Welcome you all for the last day of FDP. Today we have Dr. Yogalakshmi ma'am, Professor in Department of Environmental Science and Technology at Central University of Punjab. So I'd like to give a brief introduction about her before starting her session. She holds a Master and PhD degree in Environmental Science from Anna University, Chennai. She has 14 years of teaching and research experience, and she has published around 52 papers in high impact factor journals. She also edited a book titled Zero Waste Biorefinery and published 15 book chapters and presented papers in several national and international conferences within and outside the country. To her credit, she had completed around 35 lakhs worth research projects. Participants kindly mute the mic. I request all the participants to mute your mic. To her credit, she had completed around 35 lakhs worth of research projects from various funding agencies like Board of Research in Nuclear Science and UGC. She has developed a number of content modules of for EPG Pathsala in solid and hazardous waste management. She has also developed modules for MOOC course on solid and hazardous waste management. And she has guided a PhD, MPhil, and MSc students too. And she has organized many national interdisciplinary workshops in environmental science. So with this small introduction, I would like to invite Dr. Yogalakshmi ma'am for this session. Welcome you, ma'am.
Ma'am, your mic is muted, ma'am.
Am I audible now?
Yes, ma'am.
Okay, sorry. Thank you so much, Lavanya, for such a warm introduction. At this outset, I would like to thank Dr. Vijay Raghavan for inviting me to deliver an expert talk in the ATAL sponsored FTP program. I think this is a last day, and I hope this is the last lecture also. I'm sorry I joined a little late, and I'm not actually doing well. So I'll try to keep my presentation for 30 to 45 minutes. I hope that's okay with the organizers. So I'll just share my screen. Is my screen visible? Can you hear me? Is my screen visible?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
The slides are moving?
Yes, ma'am.
Okay. Just 1 second. Okay. So, dear participants, as I told you, for the next 45 minutes, I'll be talking about artificial intelligence, its application in environmental science and engineering. So, I'm sure we are facing a lot of environmental issues, and we are facing a lot of environmental problems as such. Starting from everyday life, you see a lot of issues starting from air quality being affected, water being affected, polluted. We talk about number of water pollutants which are there, and I mean, every day we talk about water being polluted by different heavy metals or pesticide contamination. Then we talk about waste being dumped everywhere. Then different aspects of pollution are there. Apart from that, we talk about the natural resources depletion, forest being destroyed, a number of deforestation occurring. So many aspects we are discussing every day, and we are witnessing or visualizing it. So environmental field, you have a lot of problem, you need to manage it, and scientists are working in different aspects like how to attend to these problems and all. Now, where does or how does artificial intelligence play a role in environmental application? So there are a lot of data available. We as scientists or researchers, what do? We pick up one problem and then we start analyzing it. For example, I want to monitor the water quality of particular river. So what do? I actually collect the water samples and analyze for some pollutants. It can be a physiochemical characteristics. We talk about pH, EC, and so many physiochemical parameters we do. Apart from that, we also, if you want to monitor heavy metals, you keep monitoring it. But that is only for your particular area of your particular study area. But artificial intelligence, as you all know, it is a buzzword in recent time. Of course, it is in recent time, but this is originated in 1980. From that time, if you look into if you trace back the history of artificial intelligence, it started long back from 1950 actually, and 1980 it became little popular, and only after 2010, it has been widely used in different application. Now, intelligence is something a human brain has, and how, what knowledge and how you use that knowledge that you have taken. Artificial is the machine doing the work of, working like a human being. So as I told you, like, there are different areas. People are working along different areas to monitor, to identify different problems. But when you use this artificial intelligence, it works, it tries to think like human brain. Whatever data that is available, it starts mining those data, and then it will predict what could be the future, whatever value that you as an individual or as an individual researcher, whatever you have got it, that will be used for future prediction, what will happen, how the pollutant level will increase or decrease, and all those things, and it will give a overview on a larger scale. We are working for a specific area. By doing a data mining, you can get data from for many different study areas. For example, I was talking about a river. You can take data from different areas, and that can be combined, and you get an holistic perspective of how to attend, or how you can predict like what in future, if this is the state that is going to continue, what will happen. So I'll just brief you about what is AI, and then where AI is being used in different applications, and then I'll give you some applications where, like in environmental field, some applications like where it is being used. And I'll not get into like how this AI is being done, or in environmental applications we use machine learning algorithms, then deep learning methods, artificial neural networks. And I'll not get into all these details, because that is not my area of specialization. But of course, maybe some people are from computer science, maybe they'll be knowing it better. So I'll not be getting into like the methodologies or the protocols of how it has to be done, but I'll give you an overview, like where and how this is being used in different applications. So let's talk about what is AI. And as I told you, intelligence, artificial intelligence means it's a capacity to learn and solve problem. And artificial intelligence is how you simulate a human intelligence. How machines can act like humans, and how the like just like human beings, how they can solve the problems. Like human brain, they think, they'll try to solve the problem. Same way we are training a machine to solve those problems. So it is an ability to solve the problem, ability to act rationally, and ability to act like a human. So that is the basic of artificial intelligence. Now, if you look into that, a brief definition says that it is a science and engineering of making intelligent machines, especially using computer programs to achieve whatever goal that you have planned for. Then AI has become a universal discipline, and it is being used in a number of intellectual tasks. And it is becoming increasingly popular in various fields. I'll list on few fields where it is being used, and it is under fast development. Everywhere you look into, every side you turn, people talk about AI being used in different applications everywhere today. Like whatever you see, whether you browse through newspapers or you browse through websites or social media, everywhere you can literally visualize how AI as a tool is being developed on a faster scale. Now, as I told you, what are the different fields in which the AI is being used? Some of the fields I'll mention here. Of course, computer science, we all know it is being used on a wider scale. But apart from that, we have AI application in different engineerings, like be it civil engineering, environmental engineering, in the field of mathematics, physics, robotics, astronomy, medicine, molecular biology, genetics. Then talking about chemical engineering, chemistry, digital marketing, social sciences, forensics, precision agriculture, like that, every different field AI has entered into, and it is booming in a very fast pace. Now, why AI and environmental science or engineering? Why environmental science? Now, as you all know, there are a lot of data which has been available there. Now, how this data can be processed, and these data is very, very complex. Now, we have to process it, and that cannot be possible by a single human brain. Where again, if you have to do, then you have to involve so many people. But here, AI using a machine, it can collect all the data, it can mine up all the data, and then it can bring into a consolidated form, and it can predict a future, or it can provide solutions. So environmental science and engineering, it's a complex issue which arises from different different natural environments, which can be a problem associated with soil, problems of water pollution, problems of air quality, then about the biological data in terms of biodiversity, nature conservation, wildlife monitoring, so many. Now we all know, like now gathering data from various sources is one aspect which we are doing as researchers. Many people across the globe or across India, people are doing that. So that data is available, and with that data, you have to give a holistic perspective. So gathering data from various sources, which includes, it can be a demographic information, or it can be an energy usage, or it can be socioeconomic factors. Every data that is being collected, it is potentially used by artificial intelligence to predict future environmental conditions. Now, by integrating a big data with artificial intelligence, you can do a modeling study, you can monitor, and also predict, and you can also provide solutions in terms of research. Now, we all know environmental data, it's very complex and it is very challenging, and it varies from region to region. Whatever pollution that we find here, or the concentration which is here with respect to a particular study area, that will not be same in an area which is away, maybe even 100 kilometers or 200 kilometers. So the data, the environmental data is highly complex, and this complexity does not allow the professionals to work on it. So to overcome this, we are using artificial intelligence. Fortunately, a lot of computer programmings have come today, with which we can have a precise prediction. You can do a continuous monitoring, and you can evaluate the risk, and also provide solutions for the same. Apart from this, you also have other valuable advantages. Now, AI possess, I mean, the capability of AI is to have a reasoning capability, and through reasoning, it will make decision and learn from the environmental data. Now, this data, this can be used for transforming the real world information into machine understandable and usable knowledge. Now, after you do that, it can be it can also be used in decision making in a in decision making through planned pathways of optimization and then provide a solution. Now, among this, if you talk about artificial intelligence, the most popularly used tools of AI in environmental science, if you see, it is the machine learning. Machine learning and computer vision, and deep learning, it's a sub tool of machine learning. Now, what does machine do? Machine can extract data or extract information. That is what I was talking about, data mining. And that data can be used to solve the problems according to the changes that occurs and predict the future behavior. Now, ML or the machine learning classifiers, for example, I would tell you, we have a lot of illegal open dumps. I'm sure everybody knows what is a landfill and an open dump. Open dumps or landfills are places where which is used for dumping the solid waste. Now, the waste, everyday waste that is being generated at our household, and that is being taken by the waste collectors, and we all know there is a big area where the waste is being dumped. So that is called as a dump site. Now, landfill is a place where waste is dumped, but with proper protection so that environment does not get contaminated. Now, one example where MI can be used is to identify these illegal landfills. Now, if you take an aerial view, then it is easy for us to identify the location of these landfills. Instead, me as an individual sitting in one part of the country, I cannot talk about these illegal landfills somewhere in Ramanathapuram or somewhere in Tamil Nadu. So for me, if I have this ML, then I can do a data mining and then see, or I can use a satellite image to see where these illegal landfills are there. Of course, satellite image will give you the dumping sites, but the ML will dig up the data from the government websites and find, and it will determine whether this site is being allocated to landfill or not. Now, that is where the ML plays a role. You see, the satellite data is giving the location of the dump sites, and the computer programming is helping us to derive data from the government websites, whether it is allocated or not. Now, two data from two different things are merged, and with that, we are identifying where these illegal landfills are there. Landfills or open dumps are there. Now, unmanned aerial vehicle, again, I told you how satellite images can be used. We have drones coming up. Drone technology is one which is upcoming, which is becoming very popular since the last decade. So drones are nowadays used where it's been fit with camera. Drones are flown on upon, and then it takes images. With that, again, it is fed into the machine. The other data are collected. It is overlaid, and a holistic requirement of us is being attended to. So this is one example. Another example where machine learning is being popular is used is in nature conservation tasks. For example, we can map the habitats. We can model species distribution and monitor forest health. For example, another aspect which we are talking more about is the climate change. And climate change, of course, we are witnessing climate change. With respect to state of Tamil Nadu, if you see, now this year, the last year I was talking about, we were facing rainfall throughout the year. So that is one witness that one proof that we are facing, or we are witnessing climate change. Now, as a result of climate change, on a larger scale, people talk about Arctic ice getting melted and movement of species from their original area to the upper altitude. Because any species which needs a very cold climate, and due to climate change, their territory is being occupied or filled with, the temperature changes are there. As a result, they are not able to resist that temperature. They keep moving to the higher altitude for that temperature to accommodate the required temperature. So with this ML, we can find out, or the machine learning algorithms can be used to map the distribution of species and how it is shifting from one altitude to the other altitude. This is again one example. So like that, one aspect I told you, illegal dumps can be identified. Then you can monitor the habitats. Like for example, there is some encroachment in the forest area by the local inhabitants or the villagers, that also can be mapped and found out using the ML. So with this, once it has been identified, then it is easy for even the government people or the government organizations to take decisions for taking protective measures to prevent the encroachment or to preserve the local biodiversity. Now, AI is also used to predict the spatio-temporal data, environmental data, and also forecast the water quality. For example, as I told you, for example, like uh, I mean, I'm sitting here and I have monitored the river water quality of Sutlej or Bias, and I have mapped it. With this mapping, whatever I have mapped, and maybe 10 years or 20 years before, somebody XYZ or might have monitored the water quality of same Sutlej river. Those data can be obtained, it can be combined with my data, and you can map it and also forecast, like year wise, what are the changes and what forecasting can be done, how in future the water quality would be there, or how the quality has deteriorated, and how it, whether it will get into the deterioration phase or it is reverting back. So that is one example in water quality monitoring. So as I told you, deep learning is one subfield of machine learning. Now here in deep learning, it's like you have different layers of neural networks are used, and these layers are used to extract information. I mean, more depth of information is extracted, and in different layers. So that is about deep learning. Now, deep learning algorithms are basically used in climate modeling for collecting the data. For example, you can collect different data. It's like the physical, chemical, and biological properties of the water, air, and land, and through the vegetation coverage or moisture or species concentration or aerosol concentration, everything can be layered, and then overall you can monitor the climate. So, what are the different fields of environmental science and engineering AI is being used? There's a pie chart which gives a representation. If you see environmental engineering, almost 20% AI application, it's there. AI is being used in environmental monitoring, like monitoring of air quality, water, soil, then energy analysis in terms of like green building, passive energy efficient building, then how much energy is consumed by in the western countries, how much energy is consumed for cooling, and what can be done to reduce the energy efficiency. Then again, AI is also being used in hydrology for models, running models like mod flow models and all. Then it is also used in restoration application. Then it is used in GIS and remote sensing. GIS, of course, I think you all know, geographical information system. Then it is used in environmental health and safety, and it is also used in risk assessment, like for after a hazard. So and in climate models are also it's used. So holistically, if you see, majority of AI tools are used in environmental engineering, monitoring, energy analysis, and climate models. The other fields are still less explored, and still there's more coming up. So I would like to show you one graph where, I mean, it's based on the articles, like the research publications, which is coming up from 2000 to 2022, sorry. For the past 22 years, what is the status of publications coming up in environmental science where AI is being used? So, if you talk about, if you look into this image, you can see a drastic increase. I mean, a gradual increase was observed till 2014, 15, and all. And after that, you can see a huge boom after 2020. So, these are the fields where it is being used. Environmental engineering, again, I told you, monitoring, energy analysis, climate change, risk assessment, restoration, hydrology, and so on. So each of these are depicted with different colors, and you can see, as I told you, environmental engineering is more number of papers are coming in that field. Now, this table I would like to summarize, like where it is being used, what are the different tools which are being used for the environmental science discipline. And I'll tell you, I'll brief you like what are the different matrices, performance matrix, how it is being done, how the training sets are done, and among the models which are applied for each monitoring, which gave the best performance and all. If you talk about the air quality monitoring, the AI tools which are used are shallow neural networks. We have extreme learning machine which is being used, and these are the performance matrices. And for air quality monitoring, Vito et al. Has reported that shallow neural networks are best for air quality monitoring. Then, if you talk about air quality prediction, there the AI tool used is multi-layer perceptron regressor, and that again they have not mentioned. Only one model is there, so best performance they have not mentioned, and it is assessed through correlation coefficient and geometric mean bias, standard deviation, and so on. The next application, indoor air quality monitoring, especially with respect to the particulate matter. Now, here again, they have used multiple linear regression, support vector machine, and gradient boosting regression, and extreme gradient boosting regression, and all. So, out of this, they say the support vector machine tool is best for monitoring the particulate matter in the indoor environment. I mean, indoor means within the house, or in the closed environment, house, office, or anything. Then real-time monitoring of water quality, again there a least square method is used. Then SVM, which is support vector mesh method, is used. Other methods like what to say, like seam-dan, variable mode decomposition, ELM, and they are also used in combinations and then tested. And out of that, they are saying VMD, variational mode decomposition, and CDM and ELM are the best method. The other applications like real-time monitoring and prediction of water quality, again long short-term memory neural network is used, and here it is used as a multivariate single-step analysis, and multivariate multi-step series forecasting is used. And the other applications are ocean monitoring and animal tracking. Some of the applications I will elaborate more in the coming slides. Again, deep learning is used here, and for energy prediction, random forest and gradient tree boosting method is used. And they say gradient tree boosting method is more best, gives best performance for energy prediction. Then about the solar photovoltaic power forecasting. Now, in this, what do they do is, what are solar photovoltaic cells, like the solar modules for, solar energy, for tapping solar energy. Now, this application, again, they have used machine learning tools, or the artificial intelligence tools, and then they have found out holistically how much solar energy is being potentially tapped for a particular region across a huge area. So here they say random forest method is best. Random forest method, they don't have any biasness. So most of the machine learning tools, or the AI tools, they use random forest popularly. Then another study is power prediction of wind turbine, where deep neural networks is used. And also hydropower production was also assessed using multi-layer perceptron as a tool. Then building energy modeling, where machine learning based regression model was used. And the other application like building energy prediction, neural networks, XGBoost is being used. So these are the list of tools, different tools which are used in environmental application. Likewise, you also see tools being used for environmental modeling, hydrological modeling, solar radiation prediction, and climate models. So out of that, you can see overall like random forest regression models, then artificial neural networks, okay, surface vector machine. So all these things are different tools are being used, and you can see I mean, they have mentioned which as a giving the best performance. When you talk about the biodiversity or the wildlife conservation or nature conservation, again, for identifying the invasive plant species or wildlife tracking or tracing of animals and natural conservation, these are the tools which are used: SVM, random forest, deep learning tools, boosted regression trees, decision tree classifier. These are different again tools which are being used. And for energy management on domestic hot water usage, I told you every house, I mean, in Western countries during the winter seasons they use hot water, and how much energy is being consumed and how that can be managed efficiently. I'm not talking about a specific area, for a big state and even for a country. So that is how big the data mining is done in machine learning. The other application is like water management and groundwater modeling, hydrological drought forecasting, where again random forest, SVM, deep learning, artificial neural networks, all these things are used. And with respect to waste management, again conditional random forest and univariate nonlinear regression tools are used for assessing waste management. And more tools which are used to map, used for waste management. Now, I'll give few examples about the environmental quality monitoring or the climate modeling, then basically about waste management and water modeling, hydrological modeling. Now, when we talk about environmental quality monitoring, I'll give one example of air quality. And air quality, for example, the specific pollutant, individual contribution of each pollutant, for example, like the carbon monoxide or the ozone, particulate matter 2.510, or sulfur dioxides of sulfur. What is the contribution of individual pollutants from different sources, as well as in areas of road traffic restriction? What are these? They studied on this, and they took data from the COVID-19 pandemic lockdown period, and that data was used, and then they predicted what is the influence of these individual pollutant on the urban area, and they used it to identify the atmospheric hydrodynamics, without the use of any atmospheric hydrodynamics and source inventories. They identified what is the role of each of these pollutant. Another study where similar to air quality is talking about the indoor air quality monitoring. Now, indoor air quality monitoring, where certain sensors are fixed inside the home and they take the real time reading, and that reading it's used to monitor and model the pollutants at the indoor level, and what time different pollutants is released. For example, within an indoor environment, when we start cooking, it releases a lot of volatile organic carbons. Then and in that also, if gas is being used for cooking, then it is a different case. And if a firewood or a fuel wood, for example, in places in the northern region, for cooking, like Himachal, Jammu and all, they use firewood for cooking. So that will release a different pollutant. For example, that point of time, especially during the cooking period, in addition to VOCs, we also have, if firewood is being used, we also have release of particulate matter, we also have release of CO2 and all. So with respect to time, different time period, what is being released, and in general, what are the other things which is being released, that taken, monitored and modeled. And based on that, what is the exact source is being done. And this is not at the individual one house data, which they model and predict what could be the overall status.
எள்ளி முடிச்சு எந்திரிக்கணும். நீ படி அந்த அந்த பக்கம் போ. நேரத்து உட்காந்து படி படிப்போம். அதே உட்காரு. ஸ்டெப் பண்ணு. ஒன்னொன்னு ஸ்டெப் பண்ணு.
Can you please mute your mic? You're disturbing. Okay. Okay, let's continue. Is my slide visible?
Yes, ma'am.
Okay, thank you. So next comes the water quality. With respect to water quality, they have studied or monitored the algal concentration. They used microbial potentiometric sensor installed, and whatever signal that it generated was connected to a machine learning tool using the LSTM neural network. And with that, by a multivariate single step and multivariate multi-step time series, it was used to predict the changes in water quality. At what point of time, how much algal growth is there, or algal increased or decreased growth is monitored. And if when they saw like the real time data and the predicted data matched so well, and the difference was less than 10%. So that is one example where AI or ML is being used in water quality monitoring. Then when the monitoring, the the AI powered tools are basically used for tracking the water quality, or what is the ocean temperature. Now here again, if you see, if you are going to go personally and then collect data with respect to ocean is vast, and you will take at certain places. But when you have AI powered tool, it will give more accurate data, because it will collect data from different places. So that is one advantage which is not possible by a single possible by the human being. So in ocean monitoring, it is used for tracking water quality, to observe the ocean temperature, to identify the marine life, and how or what sort of pollution is there. For example, if there's an oil spill or oil leakage, so we can identify those things. Now, how we go about doing this is automated sensors can be connected to data stations, and visualization tools or acoustic tools are used. Acoustic tools are especially used for certain fishes, like what to say, like the dolphins and whale. Their acoustic tools are more helpful in tracking these animals. Then you can also use physical tagging technologies, through which you can detect the stress or the behavioral changes in fishes. Now, the data that was collected can be used in computer modeling to identify the trends and predict the future effects of climate change on a particular species. Now, the ocean network of Canada and other deep sea cabled observatories, they have a lot of data basically. But earlier, the data processing was limited again. Once this AI monitoring programs or the machine learning was come, these data were potentially used and for tracking many animals, and to find their behavior, stress patterns, and their movements, the species distribution, and so on. Another study showed that how, like for example, in Pacific Ocean, they used this for identifying, detecting key Pacific Ocean fish species, where machine learning and computer vision automated pipeline was used, and the ULO neural network was used for this, and they found out almost 92% average precision here. And when video materials and other tracking algorithms was used, it was easy for them to count the number of fishes. Now, with respect to energy application and climate models, now as I told, area of research, people are trying to build energy efficient buildings, because again, the renewable resources, people are looking for renewable energy. The fossil fuel depletion is there, and then now people are looking for alternate energy. People are investing on solar energy, wind, and so on. So, in such cases, what happens is, like, they want to model or identify how a passive energy system in a passive building environment is there, and based on that, they will model and find out what energy efficient structures can be added to the building to improve the energy efficiency. Another study, I told you how like the hot water usage can be used. One study has reported almost 17% of energy was used for hot water pipes. So they are trying to use machine learning as a tool to identify that and to see or provide solutions or in decision making, like how this can be reduced. So that is another application. And also this ML or AI as a tool is also used in the weather pattern modeling or the climate modeling also. So the weather patterns are being predicted and predicted, and it has been given. Now the accuracy of the weather prediction has improved much after the introduction of AI or machine learning tools into the weather prediction patterns. Now, also, it is used for evaluating the climate adaptations and also predicting future weather changes by simulating the models. For example, here again, data, it's taken from different sources. They are using deep learning. Intricate details are collected, like the wind data, water data, precipitation. I'm talking about different meteorological data are collected, and then it is correlated with the climate models, and then exact prediction is being done, like what would be the how this year would be, what would be the changes that you expect or that you can predict for the coming years. So that is done. And also, there is one study which talks about the Arctic sea ice loss. Every time there's an organization in United States of America, they predict the Arctic sea ice loss due to different factors. Again, we are talking about the climate change is one important factor. But after, studies have shown that after incorporating artificial intelligence or machine learning, they have said like the prediction models that the United States of America it's giving, it's not very very accurate. They are giving an overestimated or an underestimated values, and somewhere they are trying to prove them that this is not the correct data. They are also using, the levels of layers of data that they are using is more. The study has used more layers of data when compared to the United States of America organization, which is estimating the Arctic sea ice loss. So this is again one big place where ML, machine learning or artificial intelligence has played a role. Next, about predicting daily stream flow or predicting daily discharge using daily precipitation and temperature data. That will help in the streamline flow. Also, if it is going to face some hydrological drought, that can also be predicted. Sorry. When you talk about biodiversity, again, some I have mentioned like how it is being done. So AI tools are generally used for identifying the endangered species, to track their movements, and also to detect the habitat loss. Now, how do they go about by doing it? Is one example of invasive plant. Invasive plants are not original or native to a particular area. They are introduced either naturally or by the anthropogenic activities. Now, these invasive plants are very harmful. They tend to what to say? They tend to kill or evade out the original species, and that is why invasive plants have greater role in biodiversity. So here, by using the machine learning algorithms, they have identified the habitats where or the pattern or the path through which these invasive plant species are spreading, and how these invasive plant species are affecting the other plant species. That is also being done. In our department, one student is working on this, like how climate change is having an impact on the medicinal plants. The Himalayas, you know that it is famous for certain medicinal plants. One example is Chatamasi. Like that, you have number of medicinal plants there. Now they are modeling using machine learning algorithms, like what is the original habitat which was there, and how this is being moving or being removed from that particular region. Again, this is successfully done with machine learning algorithms. Another example is how these species distribution models, like the what to say, like which are the areas that this invasive plants are entering into, and how the climatic conditions are favoring or it is destroying that original species are being modeled. Again, one another example of in species distribution, I told you like how climate change is favoring the movement of species from the lower altitude to a higher altitude, or the lower latitude to the higher latitudes. For example, even a number of fishes have started moving from the mid latitudes to the polar region for temperature related issues. That can also be mapped. So the habitat suitability also, like for invasive plants, a suitable habitat where it is growing, that also can be identified using ML algorithms. Then with respect to hydrological modeling, again, I told you ModFlow is one model, which is a high resolution model, which can predict the groundwater condition and also the interaction between a groundwater and surface water. Now, machine learning algorithm can be integrated with this high resolution ModFlow model, and it can be used to predict. Now, this saves time, reduces the time for modeling, and it also enables us to explore the unexplored places. Like Morphlow, I told you, it is about the groundwater and interaction between groundwater and surface water. When ML or machine learning algorithm is integrated, then we can also combine the climate change or predict the climate change and drought conditions also. Another study was done to evaluate the hydrological drought in Gidra River in Slovakia, where using ML algorithm, they were able to identify the dry, wet, and the normal hydrological situation. And they have reported that they have achieved high accuracy rates in predicting the hydrological drought. Now, when you integrate water management with machine learning models, you can predict the irrigation, you can do irrigation planning and also mitigate the effects of drought. Another field where AI is used in environmental science or engineering is waste management. Again, I told you like a conventional method where the waste collectors or the waste collection routes are being planned by the government or the corporation or municipalities. It's mechanical. You take the map, you analyze where are the roads, the connecting roads, and how to start, how to go, and then complete one collection route. That's how it is being done. Now, once AI tools are integrated, you can optimize this collection route so that you increase the efficiency of collection, and you also see like the collection efficiency, and also the energy and the human resources are being reduced. And it is also used to identify the generation patterns, the waste generation patterns can be identified. Then the sorting of waste can also be done, identified using AI tools. One researcher have used machine learning and regression analysis to identify the impact of socio-economic factors on these mismanaged municipal solid waste. And this is done basically to focus on SDG, the Sustainable Development Goals. And they have reported that the low-income countries have shown only 45% of controlled recovery and disposal rate, when compared to lower middle income countries that have achieved 75%, and the upper middle and higher income countries have recorded 100% recovery and the disposal rate. So machine learning algorithms are also used in this aspect of waste management. Another thing is like we always have faced a problem of overflowing dustbins, the bins that have been kept at the street corners and then different locations. Generally you see it overflows, and then that is a situation we have seen. Now, when you use ML or AI tools, we can detect the status of bins and also automate the recording of overfilled bins. so which is being studied by Agnew using computer vision network. This is another aspect of what to say, like integrating machine learning in geospatial technology, where you can collect the samples, measure physiochemical characteristics or the heavy metals in particular area, and you collect the satellite data, and with that satellite data and other these other datas, you can map and find out, predict the what to say, the proper different layering can be done, and you can see which condition it's impacting the heavy metal release, or what is the reason for that. So this study generated digital maps of soil elements using the Google Earth engine, and different spatial covariates were used and mapped here, and here also random forest method is being used. Then 1 minute, sorry. Sorry. So that's one. Yeah, again, again, I told you random forest is being used. Random forest method is popularly used because they don't give a biased value. They Yeah, so they don't give a biased value, and also they include both categorical and the continuous variables effectively, and so this is more commonly used for different applications. When you talk about the soil nitrogen production, again, this is one important factor where we use huge tons of fertilizers here, and without even knowing what is the exact value, and every soil is deficient of nitrogen. So if to have a proper agricultural productivity, soil nitrogen is important. So we can monitor the soil nitrogen, and using geospatial and artificial intelligence, what you can use is we can predict where are deficient regions of soil nitrogen, and then accordingly we can supplement the nitrogen deficiency in that area with fertilizers. So this is again done by collecting the soil and vegetation indices data from Sentinel satellite image, and using different environmental covariates like topographic factor, soil factor, climate attribute. All these things are layered, and field analysis of nitrogen. That everything is layered, and based on that you identify these areas, and you add the required fertilizers. So another application like microplastics is one thing which again we are talking one buzzword which is creating a lot of attention in recent times. Microplastic, though even only qualitative measures are done, quantitative it's very limited. Here, if you find microplastics, hyperspectral images can be used for identifying the microplastics, and this can be potentially integrated with machine learning algorithms to find out the places where the microplastic contamination is there. So here again, for another place where machine learning or deep learning algorithm is used is to identify how if a land is I mean the soil quality of a land is affected, what impact it will have on the economic value. So that is being given here. So these are the applications which I have mentioned so far. Now, what are the actual environmental impacts of AI? Of course, when you use AI, how this AI is affecting the environment. Now, when you use AI, because AI uses high precision computing requirements are there. So when high precision computing requirement is there, of course, it will consume more energy. when it consumes more energy, like for example, in a normal computer running and the high end system running, it will consume 2.57 times more power, more electricity than other applications. So energy consumption is there. Again, somewhere on the other side, energy, it is not energy efficient, more energy is consumed. Then with respect to time, it involves a lot of data cracking, late data mining, so a lot of time is being consumed there. Then when you talk about, of course, the carbon dioxide emissions are also more, that leads to increased carbon emission. Then on the other hand, if you see, it is very crucial to do a number of repeatability tests. So for normal running itself, we have seen like energy consumption is more, time is more, CO2 emissions are more. But when you do a lot of data mining, for reliability and performance, you have to do a number of training sets. That again will cause a lot of environmental impacts. So it is made unsuitable, unsustainable. It is unsustainable or costly option in the aspect of both environment and economy. Now, advantage wise, if you see, again, as I told you, you have a lot of data which cannot be processed by single individual, but a machine can do that. A lot of data mining, data sets, data kriging, everything can be done. When that is done, the efficiency of analysis or identifying the patterns or trends are more accurate. And also it helps in boosting the productivity or innovation across various industries. Now, it also increases efficiency by automating repetitive tasks, and it improves decision making through data analysis. And of course, cost reduction in terms like data on a larger scale is taken. So that way, I talk about cost reduction. And also, it reduces the human errors and scalability. It's very, very good in meeting the challenging demands. Disadvantage, again, I told you, like environmental, like it is costly, energy consumption, and yeah, again, machine is a machine, not a human. So you have to train the machine. So you have to do a lot of training sets, reliability and all. Only if the accuracy goes above 80, then you have to consider. Otherwise, you have to do it again and again. And so all these things are the negative sides of AI. So with this, I'll end my presentation. So if you have any questions, I'll be happy to answer.
Thank you so much, ma'am, for your wonderful presentation.
Thank you.
Participants, if you have any queries, you can ask in the chat box or unmute yourself and ask.
No questions. So everything is clear or nothing is understandable? Any questions, participants? I think last day after lunch, it is too technical and too much for them, I think. Any questions?
No, ma'am. Everyone is clear about your presentation, I think.
Okay, Lavanya. Thank you.
Thank you so much, ma'am, for your support and wonderful presentation, ma'am.
Yeah, thank you so much, Dr. Lavanya.
I request all the participants to join at 3:30 p.m. for the
So
next
can I
session.
exit?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Thank you so much
Thank
once
you.
again. Thank you, Dr. Vijay Raghavan. Thank you, Dr. Lavanya. Thank you so much. Thank you.